this example, we need to find out the force on particle 2. We have three forces, three charges, Q1, Q2, Q3, and we need to find out the force on the particle number 2. So we have force from particle number 1, and also we have the force coming from point number 3. Since we have two different forces acting on one particle, we call this kind of example as superposition questions or superposition principle. Let's find out the force on Q2 due to the presence of Q1. So we have F12 equals to K times Q1 times Q2 divided by R squared. K is 8.99 times 10 to the power of 9. Q1 is 200 times 10 to the power of negative 6. Q2 is 100 times 10 to the power of negative 6 divided by 1 to the power of 2, because the distance is 1 meter. Then it's going to be 8.99 times 10 to the power of 9 times 200 times 10 to the power of negative 6 times 100 times 10 to the power of negative 6. That will be 179.80 or 0.8 Newton. What is going to be the direction? Direction is going to be to the right, because we have like charges and they repel each other. So we have F12 going to the right. Now let's find out F32. Again, using the Coulomb's law, K times Q2 times Q3 divided by R squared. So it's going to be 8.99 times 10 to the power of 9. Q2 is 100 times 10 to the power of negative 6. Q3 is 300 times 10 to the power of negative 6 divided by 1 squared. That is going to give me 269.7 Newton. We have two unlike charges, so it means that they attract each other. So the force on the second particle, due to the presence of particle number 3, is going to be toward right. So F32 is going to be toward right. So F net is going to be the summation of these two, F12 plus F32. So we have 179.8 plus 269.7. That will be 449.5 Newton. That's the F net.